Okay, so this blog is a bit of a longie, but hopefully you'll find it a bit of a goodie as well. It's covering multiple things in it, such as the new nesting functionality inside of Inventor 2019 and the product design collection. Also top-down modelling approach, also a little bit of iLogic and sort of a combination of all those things. To start off with, we'll talk a little bit about the top-down modelling approach. You may or may not be familiar with this. If you are, then great. It's my preferred way of working inside of Inventor. However, if you're not, then you're probably used to working from a sort of bottom-up approach, which would be designing a single part and then putting that into an assembly, designing another part, putting that into an assembly and constraining them together. This method works fine, and I still use this now and again, or where the top-down won't work. But 90%, 99% of the time I can make my models from a top-down approach. The difference being is, you can see here I've got my counter. This looks like it's a full assembly, and you can see sort of the splits between the separate sort of parts, but actually this is only one single part made up of multiple solid bodies. Okay, so you can see the individual bodies going on here. To do that, it's actually pretty straightforward. Whenever you create a new feature, so I'm just going to chuck a sketch on there and extrude this up. Can you see here we've got the standard join, cut or intersect, which would join, cut or intersect the solid that it's affecting, and if you only got one solid, then yeah, it will only affect that. But you can see here, because I've got multiple solids, this feature here will join at the moment to the right hand top solid. Okay, however, if I wanted this to be its own feature, then I can come down to new solid here, and you see at the bottom of my list I now have solid 67, and I could rename that solid to box or box 2, for instance, and that's almost like its own separate entity, even though it's within a single part. Okay, now I'm going to turn that off because I don't actually want that, and go back to my sort of full counter. So once we've made this, and the benefits of making it like this are, so I can come to my length parameter here, and I can change this to 2 meters 200, for instance, and you see that every part has been updated in one quick change. Where if you're working from a bottom-up modelling approach, then you would need to go and open up the parameters of each individual component, and then go and change each individual component, which is lengthy, or you would link them back to a source model or a source set of parameters, be that sort of Excel file or just a 2D sketch. But this way it ties everything all in together, and you can see the changes happen instantly. Okay, so let's pop it back to 2.5 meters, like so, and then we need to look at how we actually can take these solids and turn them into their own individual parts, so we can nest from them, or get an accurate bill of materials, because at the moment if I put this in an assembly I'd only have one counter. Okay, to do it, straightforward, come across the Manage tab, we're going to go to Make Components. Okay, from there you can see we can assign an assembly name or place it into an existing assembly. Here, because I have an existing assembly called counter, the template function is disabled, and this will place it into that assembly. If I want it to be its unique one, I'll call it counter for nesting, put 2 on, and you see it's creating its own assembly. From there we can then select the parts that we want to take across, or I should say the solids that we want to take across, and you see here I stopped at front plinth 2, because essentially this part and this part here are the same or going to be the same parts. Now if I take this solid across, it will show it, but it will also make it as its own individual part, and that wouldn't be correct for our bill of materials. So I'm not going to take that solid through and just skip it out and carry on down the list, and we'll sort out how we can get a duplicate of that into the assembly. Okay, so all the way down, take the top two as well. Okay, I could take the box if I wanted, but I'm not going to in this case. So I'm going to hit next, and you'll see here it's got left hand top, right hand top, IPT. Okay, so these are now going to be individual part files. Because I've applied an appearance already, I can leave my use color override from the source component on. However, I could untick this, and then that would give me the ability to change the colors, textures, materials, etc. However, because I'm using the sheet metal template, even though this is wood, I'm using a sheet metal template, this will automatically assign a material to that individual part. So I've got different thicknesses going on. The top is made out of 22mm ply, the rest of it is made out of 18mm MDF. So I'm going to choose 22mm ply nest template for the top pieces, and then go through all the other pieces and choose whichever template I want, basically. So these ones are all going to be 18mm MDF. And of course you can have multiple templates set up at multiple different thicknesses, but it makes life just so much easier modelling in this way, because you can see the interaction. You can affect two parts at the same time, you know, if we're putting in cam holes, screw holes, and you know, like I said, this is a wooden counter, but I'm using the sheet metal template. So just flick through, make sure we get all of them. Right, so nearly there, and you might be thinking, oh, this is taking a long time, but obviously bear in mind, in sort of the bottom up approach, you'd be taking twice as long, if not longer than this, because you'd need to put those parts together and then actually sort of create the constraints, where with this approach there's no need for constraints. It grounds all the components but holds them all in place for you. So again, I've got two top panels at the bottom here, so again I'm going to use my 22mm ply nest. Once I'm happy, I can hit OK, and you see I have now created a assembly, but I've got the bits, a couple of bits missing, and these ones I want to be duplicates of it. Now I'm not going to use my mirror, because I'll have the same result. I'll end up with this part as being front plinth, and then the mirrored side would be front plinth MIR, and there'll be two separate parts. So instead I'm going to use a pattern. However, I don't know how long to pattern that, and because it's parametric, that pattern length might change. Okay, so I don't want to just go here and measure that and then put 1175. In fact, I want to use the parameters that I've already set up from my source component and bring those through into the assembly. To do that, I'm going to come to my parameters, I'm going to go to link, I then need to locate that original file, or the source component, and I've got my counter here. Okay, and I've got various different parameters already set up, so right hand support quantity, support spacing, and plinth pattern as well. Okay, so now that I've brought those through, I can then do my pattern of my plinth in that direction, and I'll use my plinth pattern, and you see it finishes perfectly on the end there. If I stretch the model, my assembly is going to update, but you notice how all the parts are grounded, so I can't move them. But yeah, if I change the size of my source model, then all these parts will move automatically as well. So again, let's do the same for the right hand support. So this one I've got right hand support quantity and right hand support spacing, and this one here, pattern, I'm going to do middle support quantity and middle support spacing. And finally on the end there, I'm going to do left hand support quantity and left hand support spacing. You can see fairly painlessly I now have a complete assembly made up of all the individual parts and the pattern parts as well, so all my quantities are correct. Okay, now moving on to the next bit, the nesting utility. For the nesting utility to work, each one of these parts needs to have its own individual flat pattern. Now I could go and open up each one and hit save and create flat pattern, but again that will take just a long time, especially if you're using assemblies which are sort of larger than this. So what I've actually done is, in my sheet metal templates, I've written an iLogic rule that's going to automatically create a flat pattern for me. So you can see here it's saying if it doesn't have a flat pattern, then create it, if not, then yeah, exit the edit, and then close the document up for me. And I put an event trigger onto that, so the flat pattern rule will run after the document has been saved. So when I come back to my assembly, if I save this assembly here and give everything an initial save, what we should see is this iterate through every single part in that assembly, create a flat pattern, close it up, and then move on to the next part basically. And again, it'll take a little bit, but it's a lot quicker than you going and manually opening up each part and hitting create flat pattern. But the flat pattern is also useful because we can use it to get sort of cut lengths, the shape and size of it, so bring the flat pattern extents parameter across into our own individual parameter. Say if you wanted to minus 3 mil off all the edges for adding ABS edging or something like that, again we can use this method to do that as well. Okay, so hopefully we're nearly there. As you can see, it's quite a large assembly, but now we've got all the individual parts that I can open up, you see, and the flat pattern has already been created. And I can make edits and changes to this part now on an individual level, or I can go back to the source component and make a change, and that change will then be reflected. So if I come to my parameters here, go 2 meters 200, you see that changes that. I come to the assembly, hit the update, and everything moves and updates. Ooh, apart from my pattern, did I link the wrong counter through? Possibly I did. So I use print pattern instead, and here on this parameters and use print pattern. There we go. Helps if you choose the right source component, but you see it should then update if I put it back to 2.5 meters. Makes it bigger this time. We should see it sit in the right place. Okay, cool. So now that we've got all the parts with their own individual flat patterns in them, we can then take this across into the new nesting utility inside of Inventor. So to do that, I'm going to right click on the top of the assembly and do create nest. I can choose my template file, so you see here I've got one for standard wooden nest, so I'm going to load that in, and you can do this from multiple assemblies at one time. You know, it doesn't have to be just from a single source, and obviously as you've seen, those sources can have different material thicknesses or different material types in there. Even I'm using plywood and MDF, and I'll get two nests for each of those materials basically. So here you can see all the source files and getting ticks on the ones that it's done, and we're just waiting on this one here at the moment. Oh, no errors, and it's now finished, so good. Here. So there you go. You can see it's brought in all the individual pieces from the assembly, and it's split it so the sort of source materials are showing in a different colour, because I've got the filter onto material, but you can do it by nested orientation, source, shape, or however you like. And then this time, there we go, brilliant. So you can see here that it's split up our countertops, and we're going to need 2 sheets of ply to do that, and for this one we're going to need 1, 2, 3, 4, 5, 6 sheets of 80mm MDF to fit all these pieces on, and it lists the parts that are on each of those sheets. You also get a report as well, so you can see plate size, nesting method, nesting time, so number of parts, number of plates. So you're going to need 2 of those off to do the total job. The nesting time is 0.3 hours. There's also a machining time, if I can find it. Where are you? Sorry, there, machining time, 232. So yeah, from there you've then got sort of options. You can choose your nest, choose your sheet, and you can export that out as a DXF and send it to your own toolpathing software, or you can create a 3D model for this and use the HSM inside of Inventor and go from there. Okay, cool. Like I said, a bit of a long one. Hopefully you kept up and followed, but yeah, more importantly, hopefully you found that useful. Cheers. Good luck.